One of the other static code analysis tools that I've used in the past is a tool called Ndepend. Ndepend does some of the similar things that Visual Studio does, but it gives you some ability to enforce other rules that may be of benefit to you. The big thing that it does is, out of the box, it allows you to create queries against your code. If you have specific standards in your organization, some organizations I know have standards around maximum number of parameters to any given method or things like that. You can run queries using Ndepend to help enforce those rules, check compliance to those kinds of rules, a lot of other things. You can also do comparisons between two assemblies. So if you have two versions of a DLL and you want to know what's different, it's one of the few tools that I've been able to use that can create an accurate difference between them fairly easily. Again, it's one of those ones where you have to kind of try it to see where it fits into your organization. Do you have enough rules in your organization or standards that you want to put in place where this kind of a tool is beneficial? It does give you a very interesting look into your application. You can create charts that show the size of each individual component of your application in relation to others. You can look at that in terms of lines of code, lines of IL code, and a number of other things. This happens to be a look into the .NET Nuke DLL, and you can see that some sections, for example, the skin, which controls the entire user experience, is a big portion of the application in comparison to the text editor control or things like that. So you can see, sometimes you can see unnecessary complexity in a visual way. If you go into your application, you have this one chunk that's taking up half of your application, relatively speaking, and it's not anything complex. Kind of an interesting way to look at your application, though. It just gives you a different view into what you have together. The other thing that you get, one of the things that I find beneficial, especially when inheriting a new project or trying to take over something that you may not have had before in your organization, is the concept of a dependency view. What this does is, after it does the analysis of your code, it takes a look at all of the pieces of code that reference other assemblies. And that's not just other assemblies that you may have created, but it's also looking at dependencies into various core .NET Framework assemblies. So you can identify quickly, to run the .NET Nuke DLL, I need all of these other DLLs. You can quickly identify exact dependencies on those DLLs, and you can also see the level of dependency between the DLLs. For example, there's huge dependencies to System Web and MS Core Live from the .NET Nuke DLL. .NET Nuke's an ASP.NET application. Makes sense that you have a lot of dependencies to System.Web and obviously the .NET Core. As you get to large, complex applications, this is a great way to be able to go and take a look at how everything interrelates. You can select a mass of DLLs, and it'll analyze everything and show you the interdependencies between them. Why do I talk about two different static code analysis tools? Like I said, it's just all about the feature set that you're looking for. FXCop, bare bones, looks at the Microsoft best practices and pretty much cuts it off at that. Doesn't give you anything to, look at relative dependencies between one DLL and another. Doesn't give you the ability to compare. It's just looking from, does it meet this rule? Does it not meet this rule? Etc. One of the things that we do a lot with some of the clients and things that I've worked with in the past is sometimes everybody uses FXCop and two developers do a final review through another tool, things like that. It's not necessarily something that everybody needs to have. But in the end, it really just gives you a number of things. Depending on what you're trying to focus on, if you're trying to focus on metrics, there's also a bunch of metrics that you get out of Ndepend, and you can get from the premium editions of Visual Studio. You can get cyclomatic complexity and things of that nature as well out of both tools. If you're using professional Visual Studio, you don't have access to those metrics at all and I am not aware of them existing in a standalone basis. So depending on what you're looking for, you can do that. But in the end, this is a preemptive way with minimal effort from the development team, right? You're not doing any real test plans or anything like that. It's just an extra step after you compile your code. You can identify some things that may be performance related. You could, in theory, run only the performance best practices analysis and leave it at that if you want to try to help improve quality in your applications. A lot of times that's where I start out with applications, because you would be amazed at how many applications that have been in the wild for a long time have a lot of things when you run the performance analysis of it. Any questions about the static code analysis, FXCop, Visual Studio, anything of that nature?
I have a question. In this scenario, for example, there is a scenario that is slow. Can Independent help identify the path the scenario goes through or not?
Not necessarily, but what you can do is, if you're in a specific portion of the application that may be leveraging other things, you could see in there, for example, if you're looking at an application and one of the things you can get out of a tool like Independent is where in the application, this page is slow. What you can do right away is, if I was looking at a slow page and it was in this little itty-bitty box down here in terms of overall complexity within my application, then I would really be concerned that I was spending, this one is showing lines of IL code. I believe one little box is 10 lines of IL. So if I was in this method and it was taking forever, I would be really concerned. But if it was something in here, then you can at least, what it's going to do is it's going to give you a little bit of an idea of, does it make sense that it's slow? Tracing it down, not necessarily. If you have a specific page that's slow, the static analysis tools are not typically going to help you.
What is the best query that you would use in Independent to verify that slowness?
Yeah, a couple of the big ones and actually they come in Independent by default. Looking for methods with high IL nesting depth or ones with high cyclomatic complexity. Those are typically the really big hit ones that are going to cause some sort of a problem. If you have ones with Microsoft's recommendation for IL nesting depth is no more than 10. I can't remember the exact Microsoft number, but one of the things I found with a lot of cases, if you have a method that continues to nest all the way down and you're 40 layers down in terms of nested calls in the stack, those methods are typically more complex and typically more prone to have performance-related items, as well as ones with high cyclomatic complexities. Those are also more prone to having performance-related issues. If you're interested in Independent, if you look on their website, they show you the base set of reports that they give you, and each one of the queries that they have, they actually provide a solid description as to why that query is important. And there's a couple of them in there that are specifically performance related from a query perspective.
I have a quick question. How do you determine if the page size weight is too large? How do you improve that? There's a .NET application that I got from the vendor, and we went through the performance testing, and the result based on performance testing is say the application somehow every page, the page size is really large and it needs to improve. How do you improve? Okay,
so you're talking from like a ASP.NET perspective, the HTML, CSS, images, etc. is too large. Okay.
They say it's page size too large, it needs to improve. So how do we,
Page size is one of the really hard ones. From an ASP.NET perspective, and unfortunately, none of the things I'm going to talk about here specifically deal with page size, but what I can tell you is if page size is something that is a problem, a lot of times, depending on the application, is either related to a master page design if you're working with traditional ASP.NET stuff, or if you're working with a CMS or something like that, it's a skin or something, whatever it may be called in the platform of choice. The fastest way to see some of that in terms of page size is using a tool called Fiddler. What you can do with Fiddler is it inspects all HTTP traffic that you're looking at. So what you can do, you can start Fiddler, load the homepage of your application. You can take a look at the web requests that are executed. What you can see out of that is, okay, I have 100 web requests and each of them are 25K plus. Okay, that's a problem. You can also, with that, especially if you have one that has a heavy page size, if it's all static images, one thing that will have at least a minimal performance impact in the beginning is making sure that all of your static content is cached. So what you can see with Fiddler too is, so I have 100 images. Am I downloading those 100 images on every page load, or are they at least cached for a period of, a day, 7 days or something like that? So at least we're only checking, hey, has this changed? No, and going through from that perspective. Page size is the only one that, honestly, I've never found an automated tool that's going to do a lot with it. It's really about, why is this HTML too large, or why is this page itself too large? And it's looking at the CSS. It's looking at the images. Sometimes, the most common thing you see, especially with anything with user-driven content, the most classic example, homepage content has an image that's 200 pixels by 200 pixels. They want to know why it loads line by line as the page loads. You right-click on the image, you look at it, it's a 15 megapixel picture that they took from their digital camera that wasn't resized. They uploaded it, set the width and height, and thought, we're good to go. In the end, it was a 7 megabyte JPEG that could have been done with a 60 kilobyte JPEG if it would have been resized and then uploaded. So a lot of that one is really digging in page by page, request by request, and looking at what's there behind the scenes.